Okay, guys, Unit 8 is our next unit, and we're going to be talking all about chemical quantities. Okay, so in these chemical quantities, the first one we're going to be discussing is the mole. So the mole is our chemical dozen. That's kind of what you need to keep in mind. Like a dozen is a counting unit for 12, like 1 dozen anything is always going to equal 12. Well, the mole is going to be the same idea. Obviously, not the same number, or we wouldn't need it, but it's going to be the same idea where it's like a big quantity of items. So, unfortunately, we can't count we can't count just atoms in a compound. Like normally we think of like, okay, if I have 1 iron, 2 oxide, y'all think this is like 1 atom. This is incorrect, okay? That's not 1 atom. That is 1 mole, and we'll discuss what a mole is. But atoms are so tiny that there's no point in trying to separate individual atoms. So we count the big quantities that they tend to come in, such as the mole. Okay, the same reason like with eggs, for instance, we don't say like, how many eggs do you want? Do you want 3 or 4? No, you want either half a dozen, or you want a dozen, or you want 18, something like that. Like you don't count individual eggs, but 12 is not a big number. Whereas the number for mole, this number we're about to learn, is very, very big. So we are always going to count in moles and not atoms, okay? So we count in moles based off of this guy named Avogadro. This is a guy you need to remember. So he has a number named after him. It's this number right here. After dealing with some gases, he realized that at standard temperature and pressure, no matter what the gas was, there were always the same number of molecules present. And that number was 6.02 times 10 to the 23rd. So this is the number for mole. That number is equal to 1 mole. And this can be 6.02 times 10 to the 23rd, anything. It just has to be items. Okay, now don't get that mixed up. 1 mole is 6.02 times 10 to the 23rd atoms. It could be molecules. It could be ions. Let me tell you what it cannot be. Last year, people thought that since it could be any of these things, it could also be some other counting units like grams. Okay, but grams is not a thing. That's a measurement of how many things. So that will not work. All of these items, 6.02 times 20 to the 23rd items, have to be tangible. So we're going to think of them as limited to this list: atoms, molecules, or ions, and never anything else. Okay? So this is just our counting unit. The same way that a dozen is a counting unit, the mole is a counting unit of this many items, such as atoms, molecules, or ions. Okay? So we are going to memorize this number. Now this number seems kind of weird. You don't understand it. So I have some examples on here to tell you just how big the mole is. And that should make you understand just how small the atom is. So if we were to get 6.02 times 10 to the 23rd soft drinks to cover the surface of the earth, it would cover the earth in a depth of up to 200 miles. Okay? That's a lot of depth. So that many soft drinks would cover the entire earth up to 200 miles. If we had, let's go something smaller, if we had that amount of popcorn kernels, unpopped popcorn kernels, just covering the United States of America, the country would be covered in a depth of 9 miles. Okay? If we were to count atoms at the rate of 10 billion per second, it would take 2 billion years to count the atoms in 1 mole. Okay? So the mole is a very, very large quantity. It is 6.02 times 10 to the 23rd atoms. This is what 1 mole is equal to. It is just a quantity. Okay? So again, I'm just explaining to you that it's just a quantity down here. Like if I have a dozen cookies, I get 12 cookies. If I have a mole of cookies, that's how many cookies I get. 6.02 times 10 to the 23rd. Last year, people were getting confused with why I started talking about dozen and stuff. Just because dozen is a counting unit the same way the mole is a counting unit, like dozen doesn't actually matter. We're not going to be talking about dozen in the future. We're just trying to get you to understand that this is a counting unit, okay? That is 6.02 times 10 to the 23rd items is a mole, okay? So then we move into chemistry stuff. We don't care about a dozen of aluminum atoms, but that's just an example. A dozen equals 12, the same way a mole equals 6.02 times 10 to the 23rd. We were discussing everyday items like cookies and cars. Now we're getting into chemistry and discussing moles of aluminum atoms, okay? So if I have a mole of carbon, that means I have 6.02 times 10 to the 23rd carbon atoms. If I have a mole of water molecules, that means I have 6.02 times 10 to the 23rd water molecules. I hope you're getting the trend here. A mole always contains 6.02 times 10 to the 23rd. That's like the exponent. If I have a mole of sodium chloride, that means I have 6.02 times 10 to the 23rd sodium chloride ions. It's important to realize, though, a mole of sodium chloride contains a mole of sodium and a mole of chlorine as well, because it's a 1-to-1 ratio. So using the mole, now that we know what the mole is, you can use it to convert from single atoms. So we're going to go from single atoms to a unit, the mole. And we can use this in everyday life. We're really just going to use it in here. So this is how we are going to use what we call conversion factors. And what you have learned conversion factors in the past. You've even learned how to use them in the past. But this is how I want you to use it. I'm not an my way or the highway type person, except for right now. Okay, I want you to use these conversion factors. Goodness. I want you to use them as these fractions right here. Okay, so these are the same thing. These are equal to each other. This is also equal to 1, because if I say 1 mole equals 6.02 times 10 to the 23rd, that's equal to itself, right? It's equal to 1. Conversion factors are numbers that can change from one unit to another. So that's all we're doing is changing from one unit to another. We're changing from atoms or particles to moles. Or we're changing from particles to moles. So we're changing from particles to moles or moles to particles. Those are our two places at the monem. So the abbreviation for mole is mole, M-O-L, or N, okay? This is going to be one that you forget is the N one. Know that the particle right here, can be atoms or molecules, or formula unit is kind of like an ion, okay? So it can be atoms, molecules, or compounds, or formula units, or ions. It just cannot be grams, okay? So let's practice using this right here to determine how many atoms are in a certain number of mole. So read this. When converting, we are trying to convert from atoms to moles. Or wait, no. We're trying to go from moles to atoms. Put the unit that is on top of the previous conversion on the bottom of the next one until you end up with what should be the unit on the top of the last conversion. That's a lot of words. I'm going to show you what it means. Anytime you are working one of these problems where you have to change from units, you are just going to write down what you're given. 0.500 moles. And then you're going to say, what am I trying to look for? Atoms. I'm trying to get to atoms. Well, what conversion do we have that will go right there? Well, I just told you this conversion or this conversion. Either one will work, okay? We know that 1 mole equals 6.02 times 10 to the 23rd atoms. So we are going to use that conversion as a fraction, okay, to try to get to atoms. So what this is trying to say to you over here is to put down what you know. This is what I know. So go ahead and write that down. 0.500 moles. And I'm going to do a big old fraction bar and then a parentheses to separate the two terms. So do you see how mole is on top? It's saying put the unit that is on top of the previous conversion to the bottom of the next one. So I'm going to put mole down here. And so in this parentheses, in these parentheses right here, I'm going to put a conversion factor where I'm trying to go from moles to atoms. Well, this is my conversion factor of going from moles to atoms. So if I put mole on the bottom, You see up here, if I put mole on the bottom, that means that 6.02 times 10 to the 23rd has to go on top. So 1 mole equals 6.02 times 10 to the 23rd, and we are looking for atoms, so it's going to be atoms. What that does is this is like a multiplication fraction scenario. So since you have mole on the top, this is like saying mole times this conversion factor. And so since mole is on the top here, it's going to cancel with the mole on the bottom, and that's going to leave you atoms, okay? Now all of the numbers stay, and you just calculate so that you can get atoms. I'm not giving myself a whole lot of room, am I? So for this, you're going to need a calculator, so excuse me for 1 second while I go get one. So I'll tell you more in person how to put this in your calculator. I can show it to you, but I'm about to put what you see on the fraction bar in my calculator. So I'm going to take the 0.5 and multiply it by the top. So the top is being multiplied, divided by the bottom, which is just 1. So I'm going to say 0.5 times, open parentheses, 6.02 times 10 to the 23rd. Okay, equal, divided by 1. So it's going to be the same number. So my calculator gave me 3.01 times 10 to the 23rd. And this unit that did not get canceled follows. Well, the whole question said, how many, let me erase some of this so you have more room. How many atoms are in half a mole of aluminum? So I said 0.5 moles times the conversion factor to get to atoms. Sorry, my dogs. So since I have moles right here, I put what I know in front, and then I multiply it by the conversion factor. Remember, the only conversion factor that we know at the moment is right here, all of these. Okay, I can use either of them. This is the conversion factor to go between atoms or particles and moles. So I need to know which one do I use, the one where particles are on top or the one where particles are on bottom. So what you're going to do is you're going to look at what you're given, 0.5 moles. You see how moles is right here? You're going to use the one that has moles on bottom so that the mole will cancel and your unit will change to atom since your question is asking you how many atoms. So then the moles will cancel and your atoms will be the only unit left. So that's what you get. And then you just worry about the math. 0.5 times 6.02 times 10 to the 23rd divided by 1. And that is 3.01 times 10 to the 23rd atoms. So I gave you how many atoms are in half a mole of aluminum. Let's do the next one. We're going to be going the opposite direction. So let me see if I can be less messy with this one. Probably not, but this one is asking me for number of moles. So this is what I'm looking for. This is what I'm given. I'm given 1.8 times 10 to the 23rd sulfur atoms, and I want to know how many moles I have. So again, I'm just going to write that down so that I don't forget what I'm trying to do. I have 1.8 times 10 to the 24th atoms of sulfur. I want to know how many moles of sulfur I will get. So what conversion factor can go between atoms and moles? That's 6.02 times 10 to the 23rd atoms equals what? 1 mole. So I'm going to use that conversion factor as a fraction. So let me give myself more space. Wait, hold on. So I have 1.8 times 10 to the 24th atoms of sulfur. I want to know how many moles of sulfur that makes. Okay, so how do I go between atoms and moles? The conversion factor for this is 1 mole equals 6.02 times 10 to the 23rd atoms. And remember, this right here can be written as a conversion factor like so. it can be written 6.02 times 10 to the 23rd atoms over 1 mole. Or you can write 1 mole over 6.02 times 10 to the 23rd atoms. Regardless, this is equaling 1. So you're just changing the unit, not the value. So all of this is resources for us to use. So what we are going to do to start is you're going to take what you know. This is what I know. You're going to take it and write it again. 1.8 times 10 to the 24th atoms. It's very important that you put atoms and that you put sulfur. And then you are going to multiply it by a conversion factor. I like to write this, I like to write it as a fraction bar so that I remember that everything is on the top and then divided by the bottom. So everything on top is being multiplied and then you're dividing where the fraction bar is. So I like to do the fraction bar. You can do whatever you want to do. And a lot of times I take these lines and instead of curving them, I just write them straight. But it's the same idea, like you're still multiplying by whatever's right here. So again, I'm trying to get to moles. I'm at atoms at the moment. So whatever's on top, you're going to put on bottom. Just going to put atoms. And then right here, you are looking for a conversion that has atoms. Okay, the only conversion that we know at the moment is both right here and right here. We need to figure out which one matches this format. Well, since this one has atoms on bottom, this is the one I'm going to use. So I'm just going to rewrite that. 6.02 times 10 to the 23rd atoms equal 1 mole on top. Okay, once you do this, you're going to go check, is what you're looking for on top? Well, I was looking for moles, and moles is now on top. So if that's the case, then you are just going to say equal moles. I don't have enough room. This should be like written. Let me give myself enough room. I just drew my thing too big. So when I know that I have what I'm looking for, moles and moles. When I know I have what I'm looking for, I'm going to write an answer bar and my unit out to the side. Okay? So the reason this works is because I'm looking for moles and atoms cancels. The word atom, the unit atom cancels. Now the numbers with it do not, but the word does. And then what I have left is mole. And mole is what I'm looking for. Since this matches mole and mole, then I know that I can say equal and solve for my answer. Now, the atoms cancel the word atoms, but the units do, the numbers do not. So now I'm just going to put in my calculator 1.8 times 10 to the 23rd, fourth, in parentheses, times 1 if you want to. See, we're multiplying the top, dividing by the bottom. Divided by, open parentheses, 6.02 times 10 to the 23rd. And then whatever answer you get, you're going to put right there. So let me put it in my calculator. Open parentheses, 1.8 times 10 raised to the 24th times 1 or whatever, close parentheses, divided by 6.02 times 10 to the 23rd. Make sure you put that in parentheses as well, equal. And I get 2.99, okay? So I get about 3 moles of sulfur in that amount of atoms that I gave you. So the whole question asked you, how many moles are in 1.8 times 10 to the 24th sulfur atoms? Well, all I did was use my conversion of moles to atoms or atoms to moles. I put atoms on bottom so that atoms would cancel, and that gives me moles on top. I put 6.02 times 10 to the 23rd with atoms because that's where it goes. It goes with atoms, okay? And 1 goes with mole because mole is the bigger unit. You're always going to put 1 with the bigger unit, which is mole. Normally, you're going to put 1 with mole anyways, so you can just keep that in mind. But anyways, so then since atoms canceled and I'm left with moles, that means I put an equal sign and put mole and put an S because I'm dealing with sulfur the whole time, okay? And then I just did in my calculator 1.8 times 10 to the 24th times 1 divided by the bottom, which is 6.02 times 10 to the 28th, and I got 2.99 moles. Okay, so this one is asking you something a little different. This one says, how many ions of fluoride? So I want to know, question mark, ions of fluoride are there in 0.23 moles of iron, Fe, plus 3 fluoride. Okay, for this one, you have to use the formula first because I'm asked for fluoride, not iron fluoride. So I need to know how many irons and how many fluorides are in the compound iron 3 fluoride. So right here, I made the compound and I have 3 fluorides per every iron. I have 3 fluorides per every iron 3 fluoride. So what I have to remember is that I'm not asked for ions of iron 3 fluoride. I'm asked for ions of fluoride. So I'm going to start up my conversion factor by putting 0.23 moles of FeF3. Okay, so the first thing I have to do is try to get to moles of iron fluoride because I know that moles equals 6.02 times 10 to the 23rd, whatever I want it to be. I specifically want it to be ions of fluoride, so I need to know moles of fluoride. This part right here has to match, okay? So the first thing I'm going to do is say how many, since I have mole of Fe3 on top, I want to put mole of FeF3 on bottom. And I'm trying to get to mole of F so that I can get to ion of F. So it's just like using the ratio. 1 mole of iron 3 fluoride, you can see has 3 fluorides in it. So I'm going to say 3 moles of F minus 1. That's how many fluorides are in 1 mole of the compound. So now that I'm in mole of, you can see I'm in mole of F minus 1. That's still not where I'm trying to go. I'm trying to get to ion of F minus 1. So I can use this conversion factor I just taught you. And since I have mole of F on top, I'm going to put mole of F minus on bottom. And I can use Avogadro's number to get to ions because ion is just a piece, just a thing. So 1 mole of F is going to equal 6.02 times 10 to the 23rd ions of F. Now my mole of FeF3 cancels with my mole of FeF3. My mole of F cancels with mole of F, and I finally have 1 unit left, which is ion of F minus. And that is what I'm being asked for. So that means I'm putting my equal sign, putting my answer blank, and I'm going to say ions of F is what I'm searching for. So now in my calculator, this is what I'm going to do. I'm going to multiply everything on top. So 0.23 times 3 times 6.02 times 10 to the 23rd divided by all the numbers on bottom, which are just ones. So divided by 1. So again, in my calculator, that's 0.23 times 3 times, open parentheses, 6.02 6.02 times 10 to the 23rd equals, and then divided by 1, which you don't have to do. So my answer on my calculator is 4.15 times 10 to the 23rd. So this is how many ions of iron I have in 0.23 moles of iron 3 fluoride. So this one was a little different because it was asking you for ions of fluoride. So this is a multi-step problem. See how we have 1 step right here, 1 conversion. We have another conversion. This is a multi-step. That's all we're going to do for today. Let me know.